Professor Alan Penn was really the person who started all this, the CBC. Alan is a professor in architecture and urban computing at the Bartlett Faculty of the Built Environment. He is the founding director of Space Syntax Limited, a UCL knowledge transfer spin-out with a portfolio of over 100 applied projects per year, including whole cities, master plans, neighborhoods development plans, and individual buildings. He is a board member of the UCL Consultants Limited and a member of the Space Syntax Laboratory within the Bartlett School of Architecture. He was the chair of the Architecture, Build Environment and Planning Subpanels 16 and member of the main panel C for the Research Excellence Framework 2014. He is principal investigator of the $5 million 5-year EPSRC funded Digital Economy Hub at UK Region's Digital Research Faculty or Facility. Okay, so it's a pleasure to have Alan here to give this opening keynote on our third day. So with no further ado, thank you, Alan, for being here.
Thanks very much. One minor error, obviously, in my bio there. I'm no longer on the board of UCL Consultants Limited.
Oh, okay.
That's fine.
Oh, so we took it.
It's probably out of date on the website.
UCL website. Yeah. Okay. Yeah. All right.
Must change that. So my job this morning first is to welcome you all, and then what I want to do is to take the helicopter view. I want to just sort of take a step back from blockchain and construction and so ask the question, why? Why blockchain? Why construction? And obviously, I'm going to say there are very practical and pragmatic reasons that we will go into in great detail in the conference and have done over the last couple of days. You know, it's all about information transfer, integrity, the way we do BIM and so forth. But I'm going to hop in the helicopter and try to just take a higher level view. So society is going through a transition. And we are obviously at the moment not only going through a transition, but a crisis, a global crisis in terms of COVID and a pandemic. So let's ask a question. You know, what's the advantage of disease and plague in evolutionary terms? You can ask a similar question about war. What's the evolutionary advantage of war? Why do societies engage in these absolutely irrational things? At least with diseases, they're not potentially a matter of human agency. They just occur. So what we've seen with COVID are a couple of things. I mean, the first is a phenomenal highlighting of inequalities in society. And these are now absolutely obvious. They've been amplified by the disease. And they make it politically unsustainable, I would argue, to continue to ignore these inequalities. We have to deal with them. The second thing they've done is they've been an absolute catalyst to distance working. Just a year ago, we would have been carrying out this conference face-to-face. Now we're doing it entirely by virtual means and virtual platforms. Many people are working from home who would never have contemplated doing so a year ago. And the fact that it's possible to do that, and it's as smooth and easy to do that, has been, I think, an astounding transition in society, both in people's belief that these things are possible, but also the fact that the technologies have managed to support it so smoothly and so easily. But the other thing that we found is working from home is just how important face-to-face meeting is. Now, this, of course, is something which has many sides to it. We see in the digital world fake news, QAnon conspiracies, a whole range of phenomena of the digital world that seem to be exacerbated by lack of face-to-face. When you meet face to face, you can shake somebody's hand or you can look them in the eye and you can maintain trust. So there's a question here. Why construction? Why blockchain? Well, construction makes the spaces for face to face. It's what it's all about. And quite clearly, as the transition takes place to more distance-based working and more hybrid types of digital and face-to-face, we're going to need to rethink the way we design buildings, the way we put in the infrastructure that supports the digital. But we're going to have to rethink the whole way that we communicate as a society, the way we transact, the way the economy operates. So second is that in that digital world, how do you maintain trust when you can't shake hands or look people in the eye? Well, this is where I think blockchain, or perhaps I should just, reduce it to hash encoding of objects and distributed ledgers and so forth. This is where those kinds of technologies become absolutely crucial, because what they're doing is allowing you to build trust in the data which you are working with. And I think that's a key element. So putting the two together may be a key step in the transition that I would argue that society is going through. Now that's a transition. It's the thing that Ray Kurzweil talks about as the singularity, potentially. Who knows whether or not these things are true, and whether you believe in them is neither here nor there for my argument. All I'm saying is, let's take a step back and look at what's going on. So the future is going to be all about data and data flows and a data economy. Everybody talks about that. And this requires trust, immutability, and security. Everybody is concerned about cybersecurity at the moment, but these have to be built in from the base. They have some implications. I would suggest that they imply that no single central object model, because a centralized architecture is inherently vulnerable to security breaches. They also require resilience. We know that systems will get hacked and compromised. Ransomware will shut down vital data. It's happening all the time. So we know the answer. Make sure you back up. Isolate systems into subsystems with thin and secure links between them. Minimize integration. Yes, so no single system. At the same time, you need to deal with the fact that you need data to pass around. You need to be integrated. And so this sets a real challenge, I think, for systems architecture and the design of the architecture. Minimize data flows to just what is needed. Don't try to build a single model that has absolutely everything in it. The first thing is that if you try and do that, you end up with all sorts of language problems because nobody talks the same language. And here I'm just talking about how you identify categories of objects in a building, or the languages that we use to describe different policies in a policy environment, or whatever else. They're always too complicated for you to be able to construct a single dictionary that will work in an efficient way. Far better is to minimize it to just two-way flows if you can. So this agency needs to talk to that agency, and these are the shared encoding between the thin information that they need to provide between each other. So far as possible, what you need to do is to use the software elements, the applications, to do their specified job well. So beware of all singing and dancing integrated applications that try to do everything. Far better to work on applications that do one thing really well and allow those to communicate to the other applications that do their thing really well when they need to pass the minimum data from one to another. Make sure that those data are then secure and transacted in a way that maintains security. So what do we know? Blockchain, hash encoding, distributed ledgers, all one technology is going to be an important one, but there will be others. Clearly, artificial intelligence and machine learning to work on those data and to extract intelligence from these data are going to be key. They're already making massive inroads. This all needs data to be conducted in such a way that it's possible to learn. So the notion of federated learning by giving access to data across systems without transferring those data out seems to be very important. It goes out to people as well, though. So biometric ID is crucial if you want to trust the person is the person they say they are when you're working at distance and not you can't see them. That requires those sorts of things to get integrated into these systems. But then the same with objects and components and pieces of hardware. So Internet of Things, chips in things, and their identifiers are key. What this all implies is that what we're going to need are the universal data object identifiers. We need a way of holding all of these things together in a way that we can actually index and access, address and access them, and get them together into a single form. So what I'm suggesting here is that construction just does one element of this, which is it constructs the environments in which you've got face-to-face access in the new society. But at the same time, what we're doing with the blockchain element of these technologies is to build in the ability to have security and trust. And we're going to be working on those alongside a whole range of other technologies that are emerging all the time. So the key is flexibility and resilience. I would say the key is not working on single, all singing and dancing integrated applications, but working on federated, distributed, minimum thin access layer configurations, actually, which are going to change all the time. This makes for severe management problems. It makes for severe difficulty in thinking about how you structure those environments. But this, of course, is what the internet has been doing from day one. And so the knowledge exists and the potential exists to make this sort of thing happen. It just needs to be upscaled and become incredibly central to everybody's daily lives. And I think that's where I wanted to leave you. I've taken you off in the helicopter. I probably require you to parachute down. Okay, thank you.